Hello and welcome to the Global Passivhaus Showcase, presented by Passivhaus Accelerator, a catalyst of zero carbon building. We're happy you're here. We welcome all comers to our exploration of how to slash the greenhouse gas emissions from our buildings and make them more resilient to the extreme temperatures, the wild weather, and the grid insecurity caused by climate change. So, whether you're Passivhaus curious or Passivhaus expert, this is a place to learn the do's and don'ts, the best practices, and the lessons learned of Passivhaus design and construction. We'll dive into how Passivhaus design principles are applied in the real world and how this approach to construction impacts the health and happiness of the people who live and work in these buildings. Are you new to all of this? Visit the Passivhaus 101 section of our website to get started. With that, please enjoy the showcase and pose your questions in chat for the discussion session after the presentation. Thank you.
All right. So welcome everybody. Thanks for being here tonight. And we're really excited about this presentation by Alyssa Bucher and happy to have Andreas Benzing from New York Passivhaus join us as guest host today. So we'll get started with the program soon here, but before we do, we're going to go into some breakout rooms for about 5 minutes. And so in 5 minutes, please make sure you get around your group with some rapid fire introductions, and we'll see you back in a moment. So let me set up those rooms real quick here. Awesome, great to have you everybody back. I hope that was fun. So we are going to get into the heart of the program now, and in order to do that, we're going to have our guest host Andreas Benzing kick us off here. So a quick introduction to Andreas for those of you who don't know him. Many of you do, I'm sure. Andreas is a practicing architect, teacher, and social entrepreneur. He's also the co-founder and now the executive director of New York Passivhaus, which is an organization that's been instrumental in the uptake of Passivhaus design and construction in the city, and also in the policy wins that are driving the transformation there. That's all part of the context for tonight's awesome presentation. So Andreas, with that, will you take it away?
Thanks, Zach, for that kind introduction. Yeah, my name is Andreas Benzing. I'm, as Zach mentioned, I'm an architect and also executive director of New York Passivhaus. We are promoting Passivhaus here in New York City and New York State, and hopefully we'll make it also part of the energy code moving forward. So that's our mission. We already feel quite a lot of questions in the breakout room. Was interesting. A short session, but very intense, I have to say. But I'm looking very forward to the presentation. About 70% of greenhouse gas emissions in the city are caused by buildings. And we will see tonight an excellent retrofit example on how to tackle this challenge to substantially reduce carbon emissions. We will also learn how the building will fit into the Local Law 97 context, which sets carbon emission caps for New York City larger buildings starting already in 2024. So it's around the corner. And it's my pleasure to introduce Alyssa Bucher, who is a partner at Rogers Partners Architects and Urban Designers. She joined the firm in 2000, where she has led cultural, institutional, and residential projects. Alyssa has extensive experience in working on high-profile building envelopes, including a very impressive early example of a panelized limestone pressure equalized rain screen facade. I almost didn't spell it right. But Alyssa holds a Bachelor of Architecture from the Cornell University College of Architecture, Art and Planning. So without any further delay, I would like to welcome Alyssa.
Thank you very much, Andreas. This is really a pleasure to share this project. It's unusual because it is a real world application of the sort of upgrades that we need to make to buildings in order to reduce carbon emissions, and deals with all of the real world complications of working in an occupied building. And I'm going to share my screen. Basically, the project, we were engaged to come in and work on the facade of a building in New York City that was built on the Upper East Side in 1960, 1961. And the building at the time was really sort of state-of-the-art luxury housing. The rooms are very gracious and not so much designed to today's standards because the kitchens are very small, for example, but the bedrooms are twice the size of current luxury buildings. The building is white brick, and this was a very popular material in this time period. We think there are hundreds of very similar buildings, particularly on the Upper East Side, which is an elegant part of Manhattan. This is the building several years ago before we started the project. You'll see that there's a sidewalk protection installed around the building because they had concerns about things falling off of the building. There had been very significant deterioration over time of the facade. And this gives you an example of the type of damage that was coming from the thermal, probably mostly the thermal and water penetration in the brick facades. And you can see this is an example of the types of repairs that had already been done on the building. In New York City, we have something called Local Law 11, which requires buildings every 5 years to do an inspection and repair. And the tenants in this building had ongoing construction projects and repair projects with their building, and it was expensive and very tiresome. And you can see we did some probes to discover what was behind the facade. And you can see there's not even an inch between the brick and the block backup. And we found that the block backup behind the brick was also in very serious decay, with a lot of air spaces between the blocks. And they had ongoing challenges of air penetration through the building. If there was an electrical outlet in the outside wall, you could put your hand there and you could feel the air, the cold air coming through in the wintertime. So we were engaged to reclad the building. And the decision was made based very much also on bringing the building up to meet the current energy standards or the future energy standards of New York City. The larger buildings are going to be required to reduce carbon emissions by a stipulated percentages over a series of steps between now and 2050. And this is an example of the building department will come around and pin your grade up on the window of your building. So this building is evidently not doing very well. So it was a very interesting challenge to do this recladding, because even though it's a design problem, it's a very specific problem, because you can't move or change any of the window openings because you would be affecting the apartment interiors. But we wanted to get away from this really sort of super functional exterior where they hadn't spent any extra money to try and make the building elegant. And so we came up with this idea of installing these tiles above the windows at a slant, so that we would reduce the area of the flat facade and make it feel more frame-like and open and more contemporary. And we did some design studies to look at how this would look. And this is an early sketch showing the new construction. So we stripped off the brick, and New York City zoning permits you to add to the size of your building, sorry about that, without any penalty as far as a permitted floor area. And so we put about 4 extra inches on the outside of the building. We added 4 inches of mineral wool insulation, and we are using a open rain screen facade system. One of the challenges of the design was that the owners of the building elected not to change their windows because of expense. And so we needed to develop a window installation that would permit windows to be changed at a later date and provide enough access so that the waterproofing could be completely repaired and restored after future window replacement. So this was the image we had of the finished building. And the design process was interesting. We had to come up with what was our cladding material. We were looking at some precast high-strength concrete panel options. These are some design studies that we did. And then this was a tile pattern that we developed. It's a porcelain tile, and this is ultimately what we decided to go with. The idea of the design was to sort of play on the idea that it was fake stone by increasing the pixel size of a real stone image so that the pixels are about 1/2 inch by 1/2 inch. And it was kind of a way to make, let's say, something like a Chuck Close effect, where when you're a distance away, you don't see it, but when you get up close, you realize that it's not stone, that it's actually a fake stone. So here we are in Tennessee, developing the typical tiles you can see in the background there. We were studying color. And then we made a mock-up on site, testing our window frame design. Another challenge of the project was that the windows are not perfectly lined up from floor to floor or between windows on a given floor. And so we had to take up the tolerance in the width of the window frame, which does vary from window to some extent. And then this is another aspect of the project. We know that building ventilation is essential to controlling energy costs, to control the ventilation. And the original building system had really unregulated air intakes in all of the living spaces associated with the air conditioning units in each of the living spaces. And what would happen was that on the lower floors, you have a serious stack effect in the building. So the lower floors had a huge amount of air coming in. And then there was so much pressure buildup in the top of the building that the pressure was actually made up by air coming out of the bathroom vents. So this was not a desirable situation either. So we had, again, this same thing. So what we did was we introduced these dampers that regulate the amount of air coming into the building. And the dampers were introduced both at the window intakes and at the bathroom exhausts, so that the air in the building will be balanced. And this is the unit was installed underneath the, this is the air conditioning unit. It was installed below the air conditioning unit. These are the little vents, the little air intake vents on the exterior of the building. So starting construction, the first step was to do the removal of the windowsills, which had some asbestos material. And so we had to do an abatement of the windowsills. And then you have the stripping off of the brick. We started working at the top of the building and they worked their way down. And then here you can see they repointed the block, and then here they're parging the block, and you can see this is the air intake below the window. And then here you can see the waterproofing that marries the window frame to the wall, and then the liquid waterproof goes over that. And this is what you want to get access to when you replace windows in the future, so that you can replace and recreate this seal around the windows. And here, some of the windows were replaced. We have the sealant going in. We have triple seal around the windows. And then we have Becker rod around some of the windows where the windows were very proud of the wall. And then here they're installing the tubes that support the rain screen system. And then after they put the tubes on, you see they cut and install the mineral wool insulation behind the tubes. The tubes are installed with special fasteners that minimize thermal bridging. And then on the left is the final stage, which is the installation of the tile. And then finally, we get the window frames going in. And this, I took this photograph about a week ago. This is the first part of the facade that's been revealed. You can see the mismatched windows because some people had kept their old windows. And here's the building from a distance. You can see this is just the only part that's been revealed. And then here we have the existing, this is the projected performance of the building. Here, we actually don't have our starting point, but just with this facade and ventilation intervention, we're able to make the building compliant through 2034. And then future interventions could, we could figure out how to get an energy recovery ducting system into the existing shafts, which is going to be interesting. Installing low flow plumbing fixtures to reduce the cost of hot water and reduce other electrical costs. And that's it.
Excellent. Thank you very much. Zach, take it over.
Yeah, thank you very much, Alyssa. I'm going to do some quick thank yous. So everything that we do at the Accelerator, none of it would happen without the support of these fine organizations. These are organizations that are mission aligned with the Accelerator and our goal to accelerate the transition to high performance in Passivhaus buildings. So thank you to our founding sponsors, 475 High Performance Building Supply, Baxtingui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwool North America, Stocorp, and Zola Windows. Our champion sponsors are Icon Windows and SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thanks also to our patron sponsors, AeroBarrier, BR+A Consulting Engineers, Brennan Airtightness and Installation, Euroline Windows, Inotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and U.S. Engineered Wood T-Stud. All right, thanks everybody, and thanks sponsors.
Thanks, Zach. Looks like the kids are home in your house. Good stuff. We're going to dive into questions. So the first one is Mr. Scott Kennedy. You had a couple there, so I'll let you pick one.
Well, I guess the one that's the most intriguing to me is if some people change their windows and some people didn't change their windows, and you get this rating on that the New York puts on, I assume based on global energy consumption of the building. Who gets the points and who loses?
Well, hopefully the whole building will avoid paying the penalties of the New York City's. I don't know what the fines are going to be, but they could be substantial depending on energy performance. And the building in the future has left itself the option of requiring people to change out their windows.
So were the new windows that were put in triple glazed, proper quality windows?
No, they were not, but they were high performance double glazed windows. They were not Passivhaus grade windows.
So it comes down to the same question.
Yeah.
It's an interesting problem, right? If some people do it and some don't. And I know that there are penalties coming in New York for not complying. Who pays the?
Well, the expectation is that there won't be any penalties until 2034. So at that point, because we're complying with the requirements up until that point. This building is a 1960 building, and many of the residents are original owners, and they paid for this themselves. And I think there was a real sensitivity to keeping it as affordable as possible and getting as much as possible. And in fact, this evening, we also have the board member from the building who's followed the project very closely, who has really been instrumental in unifying of 160 unit owners to accomplish this project. And his name is Stefan Unger. He's here. So he can also answer questions on behalf of the building.
Thanks.
Good evening. I just would like to interject one thing regarding the gentleman who was asking the questions regarding the windows. First of all, in a co-op, which is a corporation, the shareholders own the windows. So you can't mandate putting in new windows. The mistake we made, in hindsight's always 2020, was not rolling new windows into the overall cost of the project. You learn from your mistakes. However, 40% of the shareholders did indeed put in new windows. And we probably have another 15% of the shareholders who put in windows in the last 3 years. Any new apartment renovations, and we're getting new people moving in all the time, requires new windows being put in that are Northern 1600 double glazed casement windows. Any future windows, if there's changes, must be the same windows. So we're cognizant of the issues with windows, but putting in the new facade system that we did has dramatically limited the loss of energy through the windows, because historically you lose approximately 35 to 38% of the energy through windows. And we know that number is significantly less.
Yeah, I can also mention that there were some original 1960 aluminum windows in the building, and all of those were replaced. So that was an upgrade. So at this point, every single window is a double glazed windows. But I have to say, those old aluminum single glazed windows are really beautiful. They had very narrow sight lines. But what's interesting also is that the window order was originally only about 20%. And as the windows started to arrive and get installed and people saw their neighbors' new windows, we had a whole second round of replacement windows ordered.
Great stuff. Thanks, Stefan, for joining us. It's great info. For those that don't know me, I'm Sean. I'm the question concierge, and there's lots of questions coming, and we've added more to the queue. So keep them coming, and we'll keep firing at the presenter tonight. So thanks, Scott. We're going to head over to Susan.
Oh, thank you. Yeah, so I'm up in Toronto, so I'm not as familiar with the New York City requirements. And you had mentioned that the city allows a certain distance. Is that just for insulation, not distance, a certain leeway on the building envelope if you're going to insulate it? And does it have to be, do you have to certify a passive house, or they just let you go beyond that?
For a new building, they allow you to add 8 inches to your building envelope at setback conditions, and then at a street front you're allowed to add 4 inches, and a new building has to meet new energy code. So if you can demonstrate that you're achieving your energy code, they'll basically let you have that extra space. And developers, of course, now are making very skinny high performance walls so that you get as much floor area as you can. Obviously at shared property lines where you're adjacent to another building, you can't get extra space. But that was written into the zoning code a while ago. I don't know when it was introduced, but it was in order to encourage people to add insulation.
And it's just to add insulation. It's not, there's no like performance requirement for the envelope.
I actually don't know if there's like R20 performance or something like that. But I do know that we have done it on our own projects, and it sort of comes out in the overall energy model for the building.
Interesting. Okay. And it's just interesting, the comment about some people replacing their windows and not replacing their windows. And it just comes to my mind, and I know this is not the forum for it, but think of what happened in Miami with that condo building collapsing. When you have the owners and sort of in charge of spending the money, we're sort of doomed for catastrophe if we don't have some kind of overarching, not to say that windows are going to cause that kind of collapse, but anyway, I don't want to dwell on that, but it just sort of made me think there.
Yeah.
Thank you for your presentation.
Thanks, Susan. I put you back in the question queue. Stefan, I thought you were going to chime in there. Did you want to add anything?
All I was going to say, all buildings in New York are built on bedrock, not sand. Major factor.
Yeah. Thanks, Stefan.
Yep.
And next question is going to head over to Enrique. I think this might have got answered in the presentation, but it's a good one.
Yeah, thank you. It just kind of was answered. But anyway, what is the strategy that you have then for ventilation? Because at this point, you have like a direct ventilation, and that's probably affecting seriously your air tightness. So what is
the incoming air is regulated. It's basically your only fresh air coming into the building, and it's coming directly through the facade. We did look at, there are air exchange options directly through the facade where you can have, basically motorized ventilation that does recapture energy. But it was just too complicated, and people have elegant decor in their house, and was really not desirable to start to install equipment on exterior walls in all of the living spaces. We did talk about the fact that in these older buildings, the exhaust shafts are larger than they need to be. And there could be a future retrofit where you would have air supply and return through the existing exhaust shafts. And then you would have energy recovery unit on the roof. Probably just temperature recovery at that point. But this also would be a very major construction project to do this at every vertical shaft in the building. There were other oddball things, like a lot of people have exhaust fans in their kitchens, and we are not regulating those things. So it's definitely not the perfect model. And if you were starting from scratch, you would not permit any of these kind of things. But a lot of these were existing conditions that we accommodated.
Thank you.
Yeah.
Big challenge.
Yeah, indeed. Next question we have is to John from Dayton Architects.
Great. So I hate to dwell on windows again, but it looked like in the jam details, in the plan detail, it looked like there was a little trim piece that maybe when the future window replacement would happen, those windows could get moved outboard a little bit and be more in line with the mineral wool. Is that actually what was intended there or detailed?
No, and in fact, that was an early sketch, and we ended up with a different detail around the windows. There is no real overlap, no meaningful overlap between the insulation and the window frame at this point. We are just relying on your thermal break in your window.
Okay. Still very elegantly detailed. I love the adaptation. And the Chuck Close thing was too bad we lost him recently. But
yeah.
Oh, great stuff. Okay, thanks, John. Howard S. is next in the question queue. Howard, if you're not able to come on, I will ask a question for you. Howard asked, how are they paying for the work? Are they using the PACE loans?
Stefan, do you want to take that?
Could you repeat that question, please?
Sure, no problem. How are they paying for the work, and are they using the PACE loans?
Okay, being that we're a corporation, we're not eligible to qualify for these types of loans. We were considering two different options. We were considering an assessment, which a number of us were in favor of, but because we have some older residents and some younger residents, it might have been a bit of a struggle for them to get hit with $150,000 or $170,000 assessment over 3 years. So one of the board members is very high ranking in the financial world, and he was able to go out and secure a 30-year mortgage for us at a 2.99%. We effectively raised the maintenance by about $1,000 a month, which seems like a lot of money, but for where we are, it put us slightly over the median of buildings on the Upper East Side. And the one thing that makes it even more palatable, we do not have any other major projects to do in this building. We've already replaced all of the elevators. We've replaced our HVAC system. We've replaced the ramp in the garage. And we're in the process of redoing the lobby and all the hallways. So yes, it was creative financial, and we did it to accommodate the most.
Sorry, I froze there for a second. Thanks, Stefan, for that answer. That's great. Thanks, Howard. And now we're going to head over to Yuri. I know Yuri had about 3 questions, so if you want to ask one, just because there's lots in the queue, that would be great.
Hi, thank you. Yes. I am curious how you dealt with the property line condition, if such existed, when enlarging the building envelope of 8 inches in certain, I'm assuming the entire envelope or possibly less in other areas. If you can talk about that, please.
So we did a consistent changing of the wall thickness of 4 inches everywhere. And because of the design of this building, we're not actually adjacent to any other structures. So we were able to add that dimension everywhere on the building. There are some tricky places when you have to do that. For example, we had some windows that were very close to inside corners. So we had, you know, almost pinch situations that didn't exist before. There were some people whose terraces actually got bigger because the parapet was completely rebuilt and moved out 4 inches. So, and it was made up for by pushing the wall out. So it was like the whole terrace moved out by 4 inches. It's been a really interesting project because you keep on coming up against new tricky problems that you have to solve. We're working with you know, a great contractor who's been on board with problem solving from the beginning. We had some technical help from people in our office who had a lot of experience with exterior wall detailing. We are actually not the architect of record. We brought in another architect, Rawlings, to do the final CDs and do all of the DOB submission. So we're technically the design architects, but all of the technical work was done by our office. So it's been you know, adding 4 inches to a building all the way around had a lot of interesting design challenges.
Thank you.
Thanks, Yuri. I added you back in the queue, so keep on with those questions. Next up is Joseph Martin.
Oh,
there, hold on, sorry, I just had to unmute. Hi. First, I really wanted to compliment you on the project. It's a wonderful success just to get something of that scale. Just really, really fantastic. But just kind of on the geek side, I had a couple of questions. Well, I was around for when they redid the Empire State Building, so they really, you know, they just modeled the bejesus out of that thing just to tune the facades for solar heat gain coefficients and that sort of stuff. And obviously, with the windows, you weren't able to get into any of that. So my question was, it looked like in the original building brick facade, if I read the photograph correctly, that the brick was canted out a little bit at each window, or there was some kind of little ledge or something that I'd have to go back and look at the photograph again to see, but.
No, I think that when they went
expanding at windows.
I can show that slide again if you want, but I believe that what was happening is that when they went back in and replaced a lot of the brick that had failed was above the relieving angles, and the relieving angles were right at the top of the windows. There's a structural beam that's right at the top of the windows on every floor, and that's where the relieving angle is. And they left a little bit of flashing hanging out above that, so that it does look a little odd in some places.
Okay. Right, and so, but it just got me to the shading devices, and so instead of canting it out, you've canted it back in. And
yeah,
was that modeled? Did it have any impact on that?
No, but we were actually very concerned about cutting the sky view for
that's the trade-off.
The tenants. So there was actually even sensitivity about the fact that the view was a little pinched on the sides when the building
pushing it out. Yeah.
When the building was unveiled and people saw what their view was going to be, they noticed the difference. Mm-hmm. And I'm very glad that we did not change the window head, because I feel like, especially in New York, to be able to see as much daylight as you can is really important. Right. I probably wouldn't have done the opposite in a house.
Okay, so the next good answer. The next question is, did you what were your performance metrics projected, and is the building meeting those? Do you have any sense of that yet?
So we don't know yet. We're coming into our first winter season, and the building is almost fully insulated. They're working facade by facade around the building, and so in some cases we still don't have insulation on. It's going to be really interesting to see how the energy usage is different.
Right.
Then it will be added to the story as we go.
Well, again, huge success and really inspiring. Thank you.
We have some great stuff going on right now on the podcast. We have former NASA rocket scientist and now Passivhaus luminary and leading practitioner in New Zealand, Jason Quinn of Sustainable Engineering Limited, doing an interview with Matthew Cutler-Welsh, the co-host of Passivhaus podcast. So Jason is an American expat who's now in New Zealand and doing some really cool work, including writing a book about Passivhaus in New Zealand and creating a compendium of Passivhaus construction details. So they touch on that as well as lots of other great ideas around communicating building science. So great episode. Next week, we have another luminary, Allison Bales of Energy Vanguard will be joining us for duct design for low static air handlers. So if you want to get geeky on HVAC, Tuesday is your day. Please join us. It's going to be great. If you haven't seen Allison speak, shame on you. No, but he is hilarious and also super, super sharp. So please join us on Tuesday for Construction Tech. And then next Wednesday at the Global Passivhaus Showcase, we have Sarah Bayer of Magnuson Architecture. She's going to be speaking about this round one winner of the NYSERDA Buildings of Excellence program, Rheingold Senior Residence. So don't miss that. And finally, just a reminder that FIASCon, formerly known as the North American Passivhaus Conference, is going to take place on October 12th through 15th. It is in person only. Many of us on this call will be there. I will be there. I'm looking forward to seeing a lot of folks, and please join us. It should be a great program. So that's it.